Thank you. All right. Yes. All right. As Lena said, I'm Marga, Director of Engineering at ISO Island. And yeah, before we jump into the talk, I'm Director of Engineering. What does a Director of Engineering do? So I'm a people manager. I connect people. I make sure that people have the information they need. If someone gets stuck, I connect them with someone that can help them. I also distribute the work among the engineers. I ensure that the important work gets done, even the not so fancy work, and that the load is fairly distributed. So I was talking with a colleague about this the other day, and I realized that I'm kind of like the Cilium for pods. I'm for people, right? I distribute packets of information. But yeah, maybe you don't all know about Cilium. So let me see, show of hands, how many of you have heard about Cilium before? Oh, okay, okay. A lot of people. I thought perhaps I was in the wrong crowd. All right, and yeah, so Cilium actually does a lot more than just send packets around. It has a ton of features. I will talk about a few today, but definitely not all of the features that are here in the slide. But all of these features that Cilium has are based on eBPF, which is kind of like the main topic of the talk today. So next show of hands, how many of you have heard about eBPF before? Still quite a lot of people. Nice to see. Yeah, but before we jump into eBPF, we are actually celebrating because I'm pretty sure I'm the first person speaking about Cilium after graduation. Last week, the graduation vote for Cilium passed, so we are now a graduated project of the CNCF. What does it mean to be a graduated project? It means that it is considered a project that is ready for production, that it is mature, it's stable, it's been around for a while, there's a lot of big companies using it. Actually now it's like not just the edge, the innovators that are adopting it, but like the well-established companies that are slow to adopt new things are adopting Cilium, so yeah. All right, but the topic of the talk is eBPF. So what is eBPF? Does anybody know? Does anybody want to like give an answer to this question? No. Sure. eBPF stands for Extended Berkeley Packet Filter. Yes. Although nowadays we are just calling it eBPF and not going into what it means because it's no longer a packet filter. So eBPF is a technology that makes the Linux kernel programmable. What does this mean? It makes it secure and efficient to add code into the kernel and to get the features that you want in the kernel easy, or sort of easy. You still need to understand a little bit, right? But less than what you would need to understand if you were to write a kernel module, which was like the old way of making the Linux kernel programmable, was to write a kernel module. And writing a kernel module was something that could lead to like a completely stuck machine, right? If you did the wrong thing, maybe you hung your machine. With eBPF, there's a cool feature that's called the verifier that ensures that you're not going to break your machine. And so eBPF is running inside the kernel. And the thing that it allows us to do is that to be very efficient because it doesn't need to go to the user space. It just directly operates at the kernel level. So here we have an example of some C code that is like eBPF code. It's C, so you need to understand C to understand this code. But you don't actually need to write eBPF in C. You can also write eBPF in Python. and I think in Lua, and probably other languages as well. This code is very simple. What it's doing is like when the execve call, which is the call that is used to execute processes, gets executed, it takes the process ID and puts it into an event, and then it takes it uses this helper. There's a bunch of helpers that help us get information about what's going on. In this case, it's a helper that gets the current command. So it uses this helper to put that into the event, and then it submits the event to the perf ring buffer. And so this, basically what this is doing is just collecting each command that gets executed and then putting it in a ring buffer. And then we could, from user space, we could query this ring buffer to get the information. This is just a small example, just to like give anybody that has not seen eBPF code before some idea of what it looks like. And while this is simpler than writing kernel modules, it's still C, right? And so the good thing about eBPF is that many people have already realized how cool technology it is and have written the tools for you so that you don't need to write eBPF. Right? And so you can use one of the many existing eBPF tools that do what you need to do, and you can make use of this without having to learn eBPF. So that's why, like, if you look at the market of like networking, observability, and security tools, there's a lot of them that are nowadays based on eBPF because it allows them to do very efficient and very cool things that would otherwise not be possible. How does eBPF, or where does eBPF happen? It happens on a bunch of attachment points. These attachment points can be kernel functions. It can be system calls, like the example that we saw before was the exec system call. And it can also be user space functions, but those are less useful, although they can be useful for profiling, for example. They are less useful for security, which is kind of like the subject of this talk, but they are more useful for things like profiling or tracing, debugging, etc. All right, so going into like the security for Kubernetes networking subject, the first attempt at securing our Kubernetes networking is network policies. Who here has heard of network policies? Okay. Who of you has actually applied network policies? All right, better than I expected. Many people have heard of network policies and have not applied them, but yeah, good. All right, so network policies are what allows us to define whether we want traffic to come from, to reach our pod on a certain port or from a certain other pod. This is a standard that Kubernetes has defined. It's kind of limited. The Kubernetes standard is kind of limited. It only allows like labels and ports, and that's it. But it already allows us to protect our pods and define which traffic we want to let in and which traffic we don't want to let in. In Cilium, we have a Cilium network policy. So we support the Kubernetes network policy, but we also have like an extended Cilium network policy that has more features than just the Kubernetes one. And for example, this is like a new addition that was just added in the last release. We have this new auth field, which will do MTLS. So it will do, but not MTLS, MTLS-based authentication. So it will authenticate the pods that want to talk to each other using a TLS certificate. So it's not just saying, okay, this label and this other label can talk to each other, but when the connection is happening, they get authenticated with TLS. And all of this is happening with eBPF. You can actually have network policies without eBPF, but when you do it with eBPF, it allows you to have better identity-based security. Because when you do it without eBPF, you're just using IPs. When you do it with eBPF, you can actually verify the identity of the packet that is being transmitted in the network. So, for example, we have the front end and the back end. They are in different nodes. So it could be like there could be an attacker there, right? Like it could be a rogue node. So how do you know that it is really that node, that something is not getting spoofed? Well, eBPF actually, or Cilium, inserts through eBPF the identity into the packet, and then one side of Cilium inserts the identity, the other side verifies it, and as I said, there's this MTLS handshake, so you have quite some certainty that the identity of the other endpoint that you're talking to. And as I mentioned, it's not just the labels, which is what Kubernetes provides, but you can match on like more things. It's extended and has a lot of different things that you can match your network policies on. And finally, on the network policy subject, writing network policies is not easy. And Cilium has an online editor of network policies that you can use to define who can talk with whom, which ports, and then it generates the YAML for you. So this is open for anyone to use, a cool editor. And yeah. All right. So next subject, and this is more where eBPF shines, at least for me, is eBPF allows you to provide instrumentation of whatever it is you are trying to provide without making any changes to your application and without having to run any sidecars, right? Because when you have a service mesh that, yeah, a service mesh can provide transparent encryption, but you need to run a sidecar that will take the traffic that comes out of the pod, encrypt it, and then send it to the rest of the network. With eBPF, instead of running a sidecar, we run eBPF programs on the host that will see that there's a connection that is about to happen or a packet that is about to be sent and say, OK, this needs to be encrypted, does the encryption, and it reaches the other end without the application needing to do any changes. So we can add an encryption layer to our application simply by flipping a flag. Cilium supports WireGuard and IPsec. And so you can just say, OK, enable WireGuard. And once you restart the agent so that it enables WireGuard, all connections across nodes are encrypted. And the pods, they don't see that this is happening. That's why it's called transparent encryption. But it just happens. And as I said, without sidecars, right? This is kind of like the service mesh capabilities are provided by Cilium and by eBPF without the need of adding any sidecars. All right, the next phase is observability. And similarly, with eBPF, there are a lot of observability tools. There's observability tools for debugging. There's observability tools for, as I said, profiling, tracing, figuring out what's eating your CPU, etc. And all of this allows us to again, it's kind of like a common theme of like, you don't need to do any changes in your application. You can see what are the functions, like if you're using like a user level tracer, you can see what are the functions that are eating the most time without having to do any instrumentation in your application to profile it. And you can see it with like function names and so on. So it's really cool. In Cilium, we have an observability tool called Hubble. Hubble, it has a UI and a CLI that they kind of provide different information. We added this observability tool because we realized that a lot of people were afraid of using Cilium, of using eBPF, because they were, okay, so this is super cool, but how do I debug it, right? Like, if the network is broken, without Cilium, you have like IP tables, and you can like, okay, let me see with IP tables if there are any drops, or let me whatever see all my TC traffic. When you are using eBPF, these old tools don't work anymore, and so this is why we developed Hubble and the Hubble CLI and the Hubble UI, and then recently the Hubble metrics. So those are exported into Prometheus and Grafana, and so you can also integrate them with other metrics, other tools. This is what the Hubble UI looks like. And this kind of graphic, you see very similar graphics with other eBPF tools. It's a very cool graphic. So like almost every eBPF tool for Kubernetes has this. Because it's really cool, right? When you can see these are the pods that are talking to which other pods, and like which ports are being used, who's communicating with whom. In the case of Hubble, well, this here is all green. But if there were drops, for example, because there was a network policy that is preventing a packet from getting somewhere, or for some other reason that there's a drop, there will be like red flags saying this connection is not actually happening. Like this pod is wanting to talk to this other pod, but it's not being able to reach it because there's a network policy that is preventing it. And maybe that's what you want. And the red flag is a sign of like, well, something weird is going on. Like, why is this pod trying to talk to this other one? Or maybe that's not what you want, and the red flag is a sign of like, okay, so I screwed up my network policy and I need to fix it. But yeah, all of this is like inferred through eBPF capturing the traffic and seeing who is talking to whom. And then the command line version of Hubble kind of like shows you like packet by packet where the connections are going, like what's the traffic, whether it's forwarded or dropped, if there was like a policy deny that causes a drop, and it tells you why it was dropped. All right, so moving on to runtime security. And this is like the buzz, I don't know, the thing that everyone is talking about. So with eBPF, we can not just see what is happening, but we can act on it, right? And we can act on it at the kernel level. So say you had an attacker that somehow escaped a container, right? They managed to use some known vulnerability to escape a container. And now they are trying to become root and in your system and then execute something. normally, with like your normal existing tools, you might perhaps have something that detects that someone became root. But by the time you detect this, they already became root. So, well, okay, you can stop them, but they already did it, right? With eBPF, it is possible to stop them before they actually do it. Because, well, so, okay, I wanted to actually show this slide. Because when the syscall to become root happens, you can like jump into an eBPF program that looks at this set to it call that is trying to change into root and say, well, no, this pod is not allowed to become root, no matter what's going on. This is not allowed, and just kill the process. And the syscall never finishes. Like the syscall is being executed, the eBPF program gets triggered, and it kills the process, right? So it doesn't even get to the point where it can actually execute. This is like stopping them in their tracks. And this is something that I think it's not really possible to do without this power of being running in the kernel. You can detect a lot of things, but those, if you detect like after they happen, you're too late. Right. So the product that Isovalent has, the project that does this is Tetragon, which is like a sister project to Cilium. It's also based on eBPF. We also have like nice bees. And we can detect like all of these different things that can happen, right? Like executing processes, accessing files, even like HTTP connections that, like, if there are certain paths that are not supposed to be used, like all of this can be detected, and then we can either warn or like alert, log alert, or kill the process in its tracks. Of course, Tetragon is not the only project that has this. There's a bunch of projects that are using eBPF to detect this kind of activity, right? It could be, yeah. Most of the things that are being done using syscalls. Syscalls, it's like, it can be process execution, file opening, file writing, what I said about like the set to it thing, but there's more than just syscalls. For example, changing the namespace, right? When we do, there's this command called nsenter, which is like change into the namespace of the host, the one that has all of the privileges. And that one is like, that's when you get all of the privileges. So that one you want to stop it really, really early before it gets to do any damage. Yeah, okay. And here's an example of a tracing policy. Another, it might look complicated, but it's less complicated than writing BPF code. So here, this is just a YAML file where we are saying if the set2id syscall is getting called, which was the syscall for changing into root, then just kill the process, right? And this is going to do what I was explaining before. It will just kill the process before it finishes. So as soon as this syscall gets executed, the process that called it gets killed, and it never gets to actually do the set to it. And these tracing policies can, well, maybe this one doesn't look too complicated. It's still kind of simple. They can get very complicated, but it's a structure that allows you to attach to certain certain pods, you can say, okay, these pods have this tracing policy, these other pods have this other tracing policy, and then Tetragon will take care of applying all of the eBPF programs that turn this tracing policy into actual actions for you. Okay. Oh, I thought I had removed this slide. Cool. So I only cover like the very basics. There's a ton more to learn. And so here you have some pointers to more information. In particular, I want to highlight this labs, isovalent.com/labs. These labs are interactive labs where you can try out the features that I described and a ton more features on virtual machines. So you don't need to touch your machine. You don't need to break your machine to try them out. You can, so you can enable transparent encryption and see how everything is now encrypted. And if you try to capture a packet, it will be encrypted, but the application just keeps working. Or you can try out the Tetragon example. There's a couple of known vulnerabilities, like the log4shell mess that happened last year. And there's an example showing how you could prevent the log4shell vulnerability from getting exploited by having the Tetragon tracing policy that would stop it. So if you're curious about how this actually looks in practice, I really encourage you to go to those labs. And then, so the eBPF.io is the website for all of the eBPF documentation. It has all of the projects that are using eBPF, what they are for, links to each of the projects. And then the Cilium.io website is the website for Cilium. That's it. And then also on the Isovalent side, there's a bunch of books that are available to download. These are like real books that sometimes at conferences you can get in physical form. But you don't need to get them in physical form because you can just download them for free from the Isovalent website. These two are very short, very easy. Like, what is eBPF? It's just a very short book, but it gives you an idea. And this one, which is the latest one, it's actually like a O'Reilly long book that is for people that really want to learn how to program in eBPF. It goes from like the simplest hello world to a rather complex program. So it takes you step by step towards becoming an eBPF developer. All right. And with that, that's it for my talk. And I would be really happy if you have questions. OK, I'll give it to you, and then you pass it to the next one behind.
Hi. Oh.
Yes.
So speaking about Tetragon,
Yes.
you talked about the log4j problem. Do you provide some default rules that actually help us to, for instance, well, the rule you showed us, do you actually provide some of these basic rules?
Yes, so in the Tetragon documentation and then in the GitHub, there's a bunch of examples that you can use. Of course, like you need to adapt the examples to whatever your applications are doing and so on. But yes, there's like a growing repository of tracing policies with an explanation of what the tracing policy is doing to then look for the one that fits you. And there's
thank you.
One behind.
Yes, it's working. You mentioned that enabling encryption via WireGuard is as simple as changing a flag.
Yes.
And I was wondering what happens is there some kind of intelligence when you have a running cluster with maybe productive workload that you want to enable it? So are the agents restarted in a manner that non-encrypted agents don't lose connectivity, or?
Right. Ongoing connections will remain unencrypted, and new connections will become encrypted.
Okay. Okay. So once all masters are encrypted and
No, wait. So let me explain first. Like, if you upgrade Cilium, right? Let's not talk about encryption for a second.
Yes.
The way Cilium works is that it has the data path of the packets are programmed in eBPF, and then there's an agent in Kubernetes that is like looking at whatever new CRDs you create, or if you change flags or that stuff. The agent is the one that inserts the eBPF programs in the kernel. But if the agent isn't running, the data path is still working because the eBPF programs in the kernel are still there. Like, you can kill the agent. Ongoing connections will still work. And then, so if you upgrade Cilium from one version to the next, there's going to be a moment when there's no Cilium agent running because it's like stopped for the old version and the new one is starting. That there's no loss of connectivity during this time because the eBPF programs are still in the kernel. You won't get like new CRDs applied until you have the agent running, but the existing connections will keep working. And so it's the same way for the transparent encryption. The existing connections will keep working without encryption. When the new agent comes up and sees that now you want encryption, all new connections will go through the new path, but it won't stop the old connections that are still going through the old path.
Okay, thank you.
Thank you. I was wondering, for the network policies, you mentioned that you had the new property called auth, so you could specify MTLS.
Yes, MTLS-based authentication. Yes.
Yes. Does this mean you have to implement the MTLS yourself?
No.
And it just verifies it like all other parts of the network policy?
It's transparent MTLS.
Okay, so similar to the WireGuard, which is transparent encryption between nodes, it's transparent MTLS between pods.
Correct.
Without a sidecar container or anything, I'm guessing.
Correct.
Okay, thank you.
Merci. Whoa, that's loud. I have some questions about Azure specifically.
Okay.
If that's fine. I quickly read on the Microsoft documentation that the Cilium network policies are currently not supported, and also that Hubble is disabled. Is there a good reason for that, or is there?
Yes. So this is also the same on the Google. So the Google data plane. Azure recently launched. This was launched this year, right? This thing called Azure CNI powered by Cilium, which it's a mouthful. Which is like, it's providing you Cilium performance, right? Because it's eBPF, it's really fast. But it only has a very limited subset of the features. Because Cilium has a ton of features, and cloud providers are very scared of saying, oh, we will support all of these features, right? Because they need to build up their knowledge. Because when you use Azure CNI powered by Cilium, if something breaks, Microsoft is on the hook to fix it for you, right? And so they don't want to be on the hook for everything. But it is my understanding that they plan to expand this support and support more features. For now, they have this limited set of features, and so as you said, they don't have network policies, they don't have Hubble support. What you can do is you can then use the bring your own CNI option, which was like the pre-existing option of installing Cilium, and then you have all of the features.
Yep, thank you very much.
So about the cloud providers, I was wondering about the integration between like AWS security groups, Azure network
closer. Otherwise, yeah, doesn't work. Yes.
And Azure network security groups. So are you able to write Cilium network policies that have as the destination or source a security group?
I'm not sure. I think this is a feature that we are working on, but it's not available yet. But I'm not 100% sure.
All right, thanks.
More questions? Over there.
Hi. You showed the editor for a second, the network policy editor.
The network policy editor. Okay.
Is that something we could run within our cluster and then have our namespaces and services available directly? Or is that just a UI totally uncoupled from a Kubernetes cluster in the background? Or maybe even run it on our cluster and then load our network policy that is already in there into it and then change it and then redeploy?
To be honest, I don't know. I know that when you're running, I can give you an answer that is not what you're asking, but it's what I know. When you're running like the enterprise version, then you can run this on your own cluster and generate the policy there. But I think this version is just hosted there, and so you're not running it on your cluster. I don't know if you can like provide like your YAMLs. That part I'm not sure.
Okay, so unlike Hubble, where it's connected to our cluster and we see the traffic within the cluster, this is more standalone.
Yeah, this is more standalone to like visualize what it is that you're allowing and what it is that you're not allowing. Okay. Yeah. I think that's it. I think it doesn't connect to your cluster at all. The one that connects to your cluster is like the enterprise version of Hubble. All right. Any more questions? We still have time, I think. Yeah.
From the perspective of an attacker, Cilium or eBPF is my primary goal, right, or my primary target. What do you to protect the kernel or to protect Cilium against attacks?
Right. So in order to load eBPF programs, you need to be root, right? And so I think once you're root, basically all bets are off. And so the way to protect is to allow the least amount of things to be root. There is ongoing work of doing BPF signing. So like signing the BPF programs in a way that can like provide a certificate of origin, and then only the programs that are signed, let's say by Cilium, could get loaded. This is work in progress. We have like a POC, but it's not something that can be used in production yet. Hopefully next year, this will be a thing, the BPF signing. So that would give you additional security. But again, like if someone manages to be root, they can do whatever, right? So what you need to do is to prevent them from becoming root in the first place.